It's really amazing to be able to speak with you all today, so thank you for the opportunity. This talk is really about package management for the browser. And the reason why the focus is on ES6 modules is really because they've currently been drafted into the ES6 specification, and they're being reviewed right now. So it's something on the way. And the reason why I first got interested in ES6 modules myself was because I got very frustrated with the fact that we have all these different module formats, AMD, CommonJS, and global scripts. I just wanted to see if there was a way that we could unify these, and it's very much something that ES6 is bringing to JavaScript. Through the specification, it's a specified module syntax, and it's built to support bridging the different module formats we have today. So I've got a lot of hopes for that. At the same time, in the process, it's a whole new way to reconsider what we want to think about in terms of package management for the browser. So that's what really excites me about ES6 modules at the moment. The project I want to show you is called JSPM, and it's an experimental project exploring what package management for the browser can be. And the starting point for this idea was, let's look at a package manager for the ES6 Module Loader. Think about where we want package management to be, where it could be, and explore that. And the core package management idea you want to start with is that installing something, you should just do a one-line install and a one-line require. So anything more than that, and you've added unnecessary complexity. And I think the argument is that to really get to that point where you can have a single line require and a single line install, you need to have a package manager that understands the loader. So by having a package manager that knows how the loader behaves, you avoid all the problems around configuration friction. So that's really the core idea. So let's go into it. The first thing we need is a module loader. So how can we actually start using this ES6 module loader today? Well, there's a polyfill called the ES6 Module Loader polyfill. It's on GitHub. And it's a complete polyfill for the way that the ES6 Module Loader specification is written right now. So that actually allows us to start working with ES6 modules today in the browser and Node.js on the server. It's a 7 kilobyte polyfill, so it's actually suitable for production. So just to explain what it does, it obviously gives us support for the module syntax, like you can see here. And but the really key thing that the spec authors have done is they've created this module loader pipeline. So just to explain how it works a little bit, they've based it on this extensible web principles. And the idea is that they've solved the really hard problems around modules. Things like how to deal with circular references, how to deal with interop between AMD and ES6 and CommonJS. But then they've left the exact solutions to those problems up to hooks in the spec. So we have these loader hooks: normalize, locate, fetch, translate, instantiate. And most users don't come up against the hook, but the point is that you can construct, customize the ES6 module loader with new functionality and how to interpret modules. So for example, if I customize the fetch hook, I can customize how to fetch jQuery in the example above. In the browser, your fetch hook would be an HTTP request, GET request, and on Node.js, it would be an fs.read file. Maybe you want it to be an fs.read file, and then if it doesn't exist, you loop through the Node modules folder. So it's opened up those exact implementations through these hooks. So to actually use this loader in the browser, we need an initial version of the hooks that'll work in the browser. So we need to have that fetch hook implemented and all the rest. And that's the system browser loader. And it's actually a separate specification. So the system browser loader is currently based on a Mozilla pseudo implementation, and it's a promises-based loader. If you are familiar with AMD loaders, it is exactly the same sort of usage. Apart from the fact that it's promises-based, you can basically load module names, you can load ES6 modules, and this is given to you by the polyfill, the ES6 Module Loader polyfill. And then I started this project called System.js. And the idea with System.js was we've got this basic loader that can load ES6, but we want to make it something useful that we can actually use today. We've got the ability to support AMD Common JSON globals. Let's start doing that. So I started creating compatibility layers for the loader to actually load AMD, load CommonJS, and dealing with the edge cases like things like circular references, and CommonJS circular references act differently to AMD circular references, and getting all that in. As I say, it's very much what you would get if you took one of the existing AMD loaders and rebuilt it on top of this ES6 hooks. It's got map, it's got shim, it's got a plugin system for asset loading, and bundles, which was a new feature in Require.js. And then there's this other thing called versions, which I'll explain a bit more later. So yeah, this is System.js. It's a 7 kilobyte minified in gzip project. So together with the module loader, you're getting 14 kilobytes in production. You've actually got this dynamic loader based on the technologies that are specified for the loader in the future that we can use today through these polyfill techniques. So that's the loader. The other side of it now is package management. So if we've got this loader, can we create a package manager to really simplify the process of using it? And the first thing I want to think about is the sort of timescale you're looking at for ES6 is actually a very similar timescale to HTTP2 and widespread speedy in HTTP2. So you actually, in this kind of thinking, bundling is an anti-pattern. We want to be thinking beyond bundling, and there's a good reason why bundling isn't catered for in the ES6 specification. Because it's something we're actually going to move away from over time, and yes, it will be a while still, it'll be a few years, but that's where we want to be. And not only will that make our build simpler, but the other benefit you get is fine-grained caching. So if you have a large application, you have a build of that application, you have to resend a lot of assets again just when you make a minor change. If you can have fine-grained caching with versioned URLs, you can just update the versions that have changed, and the other assets remain in the cache of your users. So it is much less re-downloading when you do upgrades. But in order to properly take advantage of this, we want to allow unique versioned URLs. You want to have a node modules folder that you can drag onto your CDN, host it as your static assets, but have those URLs versioned so that your users can get them cached, and you can just update the versions in the URLs. And then the real hard problem around package management is obviously the dependency management principles. And it's not enough to just assume that you can solve every version conflict. You will reach a point where you have two dependencies that you've loaded into the page, and they're both dependent on another dependency, but they need different versions of it, and you have a version conflict. And when that happens, what are you going to do? You can't let that break down the entire workflow. If you really want to get a proper package manager going, you need to be able to deal with version conflicts. And the way to do that is to have multi-version support. You have to be able to run two versions of the same library at the same time, and then as much as possible minimize that duplication. So we know the ranges that every package is allowed to be installed into, and then we try to minimize the duplication of versions and find the best version solution that's going to work for that. The other thing we can do is use Semver, and the more people can use Semver, the less duplication there will be. Semver is nothing more than a commitment to backwards compatibility. And if you think about that when you're building your APIs, and if we think about that as we're writing software, this whole process will be a lot easier for everyone, because when I'm in a development mode and I'm installing dependencies into my project, I can install them to the latest versions and know that the APIs are maintaining their contracts. But even with all these things, you will still reach a point where dependencies don't quite match up to what you want. There'll be one library that needs jQuery 1 and another library that needs jQuery 2, and you can't expect the system to resolve everything for you. At some point, you want to just be able to manually override everything that's going on and say, well, I just want to make sure that the only version of jQuery in this application is jQuery 2.1, and you want to be able to override that at a global level. So the idea was to have a central dependency manifest, a single place where your entire dependencies are mapped out that you can kind of control and have final say over the whole process. So just to summarize, looking at package management for an ES6 module loader, so trying to build on the principles of tomorrow and make something that we can use today. Support existing module formats and registries. Flat multi-version support, so you get the fine-grained caching benefits of HTTP2. A central dependency manifest, so that the developer has final say over the full dependency tree. But then allow production bundling today, so we have those workflows that we can actually use modules today. I'm going to dive straight into a demo and show you exactly the sort of thing I'm talking about with this. So when I was thinking of a demo, the sort of thing I was thinking of was something that resembles a future workflow, so something that we want to be doing in the browser. And a good example seemed to be web components using an ES6 module. So first we need to install JSPM, and we can do that with npm. This talk does use the internet, so if you can please take it easy on the Wi-Fi, that would be really appreciated. I can now install this component with JSPM install. And I actually hosted this component on GitHub. So I'm going to install it straight off of GitHub. So the naming system here is a consistent naming system that is used throughout. When I write this, the first thing it asks me to do is set up a local package.json for the project, where to download all the dependencies into this JSPM packages folder, the config file to create. Then it goes to GitHub, it checks the tags, looks for the latest Semper tags, uses that as the stable version, installs the dependencies, downloads the ES6 Module Loader polyfilll, the system.js loader that contains the AMD CommonJS compatibility layers, and that's our single line install. If I want to actually use this now on the page, let me just create a test page to use it. So I'm just going to load in the system.js loader, which was downloaded into the JSPM packages folder, and it's a versioned loader file. This will automatically include the polyfill itself, so we don't need to do anything more than that. And now what I have is the system browser loader extended with the functionality we want. So I can now use system.import and import ES6 and different modules. So for this application, I'm going to have a main application entry point that I'm going to load from. So I'm just going to say load app, and that's it. And that'll load app from the local folder. So I'm going to edit an app.js file. And I installed this component as GitHub Guy Bedford Markdown component. The same name that I used to install is the same name that I want to use to require. So CommonJS really is the simplest way to write modules, so I'm just going to do a CommonJS require in this example. So I'm going to require the exact same name. I'm not thinking about versions or any of those problems. And so now we've loaded the component. And to actually use this component, it's a web component. And what it does is it passes Markdown within the web component tag. And it also features syntax highlighting. So let me just show you this. So I'm just going to create a code example as well. All right. And, I've also got to include, there was a generated configuration file. So I need to include the generated configuration file in the page. So that's kind of all we need to do, and hopefully it'll work. So it's the one-line install, one-line require, and there it is. So that's a Markdown component. Thank you. So yeah, let me try and explain exactly what's going on here and how this is all fitting together. When I first downloaded the component, it downloaded into that JSPM packages folder, into a versioned folder. So it's JSPM packages, GitHub for everything that was loaded from GitHub, and then just the name of the repo with the version. So it's a versioned URL. And if you look inside this folder, we have exactly the same files that are on GitHub. So here's the GitHub repo. And the two files I want to show you is package.json and markdown component.js. If we look at the package.json, we're actually using the package.json to declare the dependencies. And the way we can do this without conflict with NPM is by interpreting the dependencies in combination with a registry property in the package.json. So when JSPM sees that you've got registry JSPM, it knows it can interpret the dependencies. If you do not like the idea of overriding the dependencies, speak to me. But you can actually also use a prefix. So we could have a JSPM prefix within the package.json, and that would also work. And then now that we know that we're dealing with the JSPM registry, the dependencies are listed first by the name that they're required by within the code of this package. So whenever this package refers to Showdown, this is what it's referring to. So that's what the dependencies mean, just as you'd expect. Showdown does the Markdown parsing, and it's also loaded from GitHub, Sambo compatible with version 0.3.1. Prism does our syntax highlighting, and it's also loaded from GitHub at the GitHub pages branch, which is the branch that Lieva uses to publish it on. I don't have to enter in the full path to Prism because it's actually in, there's a shortening service that JSPM offers, just like the Bower registry. So it stores short names against their longer names. So when there is no name given with the GitHub colon part at the beginning, it knows to just look it up from the short list registry. And then we have this CSS module as well. So those are the three dependencies. And here's the code. So this is the component. The first thing to note is that web components are really nice to write in ES6 modules because of the fact that when you run document.registerElement, what you're actually running it against is a class. So class sugaring really, really helps with that. So we can create this class xMarkdown component. Normally, we'd have to have an object with a prototype that has a created callback property. The class sugar just makes that a lot nicer to write. We can extend the HTML element very simply, and that gives us this.querySelectorAll that we call over here, which is really convenient. And then we just do the syntax parsing with a bit of really bad white space manipulation using ES6 features, and then we do the code highlighting. So it's a relatively straightforward component. But the thing I want to show you is the imports. So how are these imports working? We're importing Showdown and we're importing Prism, and the name we're importing from is exactly the same name in the package.json dependencies. Showdown, I think one of them is a global, one of them is an AMD module. We don't want to think about the interop, and the point is that by allowing each package to configure itself, you can avoid the interop issues. And just get to a point where you can require from packages directly. And that's really fundamental to that zero friction approach. And then the next thing we have is we import the CSS file. This is the CSS file within Prism to do the code highlighting style. So we're actually injecting CSS within the module system. The benefit of this is that I can deal with abstracted names in the file. I can call it Prism. I don't need to think about where Prism is, what version it is. And then I can actually start loading files from within that folder. Again, if you're familiar with AMD, familiar with those kinds of loaders, the module names are exactly the same principle. The reason why we're able to have these short names, it's just map config. It's exactly the same idea as AMD. And the way I'm loading CSS is a plugin, just like you'd get a plugin in an AMD loader. The one thing I did was I moved the exclamation mark to the end. So basically, when it comes across an asset that has an exclamation mark in the name, it reads the extension of the file, and then it looks for a module with the same name as the extension and uses that to do the asset injection. And that was the CSS module. CSS is something really fundamental, so potentially it can be brought into core at some point. But because the way the injection works is still kind of developing, it's nice to have it as an isolated module. So it's not even really part of JSPM. Anyone can create their own plugin to do like template parsing or other types of injection. And the way the injection works is it simply injects a link tag into the head, waits for the onload event. And when the onload event's fired, that returns the fetch hook and the loader hooks. So plugins just override the loader hooks of the ES6 loader, and then it's taken as loaded. So none of this code here will run until that CSS has been injected into the head and completely finished loading. And in that way, you get this really nice dependency tree of multi-asset types with the abstracted naming. And it's an approach that I really like. You don't have to use it. It's not mandatory. But it would allow me to do the nice demo. All right. So let's make this site look a bit nicer. What I want to do now is install Bootstrap, just to give it a bit more of a nicer theme. So again, I just want to install it by name. I don't really want to think any much more than that. So I'm just going to say jspm install Bootstrap. And Bootstrap's also on GitHub. It's got releases on GitHub, so it actually downloads from the release archive, but it does the same tag lookup, works out the versions and all the rest, and then for the dependencies. The reason why Bootstrap can install is because it does have some JSPM metadata in the package.json. Now that I've installed Bootstrap, in my app file, I need to require it. So I'm just going to say require Bootstrap. So it's the same name. And then let's just see that we've got it in the page. OK. So again, injecting the CSS dynamically through the module loader. All right. So now we want to take this site and put it into production. If you look at the network tab at the moment, this is obviously not at all suitable for production. We are parsing ES6 dynamically in the browser, so the system.js is loading in Tracer to do the parsing, which itself is 500 kilobytes. There's a lot of stuff going on that we don't want to be happening in production. We've got 21 separate requests of all these files. So how can we take this and make it something that we can actually put into production today and that can work? So we do need to do a bundling approach for this. So to make a bundle, what I need to do is create a bundle of a specific module. And in this case, we have that app module entry point. So I'm just going to bundle app. And again, the naming system is exactly the same naming as you would use in your requires. So I can actually bundle any module within my current required tree. Bundle app, and let's call the file app.build.js. So that'll go into app, trace the dependencies, and bundle everything together into one file, transpiling the ES6 into ES5. So there we have the build. And then I need to include this in the page. So I'm just going to say include app.build.js. Because I used an ES6 component that used class syntax, I actually need to include the tracer runtime as well. It has a class helper called create class, which I need to include through the tracer runtime. So I need to add that. Ideally, you wouldn't actually, if I wasn't using ES6 modules, I wouldn't need to do this at all. So if I was just using AMD and CommonJS, this wouldn't be an issue. Okay. So now if you look at the network tab, the same code is now running in the page, but we're loading everything from the single bundle. So that's transpiled ES6, CommonJS, AMD all running together in a single bundle in a way that supports all their circular references together. And just to give you some idea of what it looks like, it uses this two variations of system.register, and it's just kind of wrapped everything up in these wrappers. So that's how it works. All right. Then there's one other example I want to show you, which is how we can load from other registries. And also what happens when you have deeper dependency trees. All right. So what I'm going to do is install a demo directly off of npm. This is a demo created by Mykola Lysenko. So it's he's kindly given permission to use it. And I'm just going to go ahead and install that. It's got quite a big dependency tree, so it's going to take a while to install. I'm just going to leave that going on the side. So let's get that going. And I'm just going to add a button to the page so that I can click this button and load this stuff dynamically. I'm going to be kind of lazy and just do an on-click event. I wouldn't actually do this normally. So the thing I want to import is exactly the same name I just installed, which is npm voxel demo. All right, so it's gone through the dependency tree and installed and resolved versions and done all that stuff. Let's have a look at the page. So we've got this button, and this is the one where it's quite fun to watch the network tab go. It's over 60 modules, about 120 requests. So let's run that. And you see it runs, they're all CommonJS modules loading in the page, and there it's finished. Let's see that. So yeah, it's a full WebGL demo running in the browser. It's using the same Node libraries as Browserify, so it's pretty much replicating those kind of principles, and dynamically compiling that all in the browser. Again, how do I actually use this in production? So how can I take this into production? Well, I can do a bundle just like I did just now. Actually, before I do that, I want to just speak about the configuration file and show you what's going on with all of this. So here's the configuration file. If you're familiar with AMD, it's simply map and paths config all the way through. So we have paths config setting up. When I said npm voxel demo, it's loading from JSPM packages npm. So it's just a path setup. And then the way that I can load, for example, just bootstrap by name is map config. So we have global map config that says when I require bootstrap, what I'm actually loading from is GitHub Twitter Bootstrap version 3.1.1. And then the next thing we have is contextual map config. And this is really valuable. It's the way that we can abstract the naming. So Bootstrap can refer to jQuery by name, and something else can refer to jQuery by name, but they can have different names. And this was pioneered. I mean, this stuff was all developed within the AMD world. We're just redoing it here. There's nothing really new. So here's Bootstrap version 3.1.1, and you can see it's loading jQuery. And when you write jQuery, what you're actually getting is GitHub components jQuery 2.1.0. So it's global map config, which is the one without the object, this one, and then contextual map config. So within Bootstrap, these are the names. So every package can have its own names. And that's how you can easily do the multi-version stuff. We've got quite a deep tree now because I installed all that stuff from npm. And then at the very bottom, we've got this versions. And this is the final version solution currently for every package in the page. So we can see every version. And there's actually, when I installed from this npm module, it created a few version forks that come up as arrays in the version map. So, for example, GL Shader, we're currently running 0.6, 0.0.6, and 0.0.5 together in the page. I don't want to be doing that. So what I can do is I can check this configuration file into version control. There is no state in the JSPM packages folder. There's no information about versions in there. It's a universal kind of property. And I can just modify this versions config here and say, I actually just want to be using GL Shader version 0.0.6. And this is how I can go through and manually manipulate my own version tree. The problem is I'm going to now have some unfulfilled dependencies. So I'm just going to search through the dependency map and see what is using version 0.0.5 so that I can remove it. So here's the first thing that's using GL Shader. It's calling it by name, GL Shader, and actually getting this full version 0.0.6. Where's the next one? Here. So npm AO Shader is actually using GL Shader compatible with version 0.0.5. And that's what was causing us to need to fork and run the second version. So I'm just going to update this here to 0.0.6. We can now check that into version control. And that's a version upgrade. I've changed a dependency, sub-dependency, but because the full version manifest is in one place, I can have final say over that. So I'm just going to rerun the page one more time. We're now running just that 0.0.6 version. We've resolved the fork. And then I can now test it and see if it's still working. And it is. So we know that that's worked. And that's how I can have full control over the dependency tree. So now I want to bundle this for production. So I'm just going to do JSPM bundle again. And the same name, so the name that I'm writing here will still go through all those map config things, and et cetera. And let's call this voxel bundle.js. So that creates a full bundle like a Browserify bundle. But we only want to load this in the page. So someone might never click that button. It might be a pop-up that features new functionality or something. So you might not want to load everything up front. I just want to load in that new functionality when someone clicks the button. So what we can do for that is something called bundles config. And it's a feature in Require.js today. So again, I didn't invent it at all. So we call this voxel bundle. Was that the name I gave it? Yes. So the local name, I would type import voxel bundle to load that bundle. So I use that name, and now I can say what the bundle contains. So what modules are inside the bundle. And what that means is anytime I request one of these modules that up front has been declared as belonging to the bundle, it'll make sure it's loading from that single bundle. I have to now enter in fully normalized names because bundles contain normalized module names. So I'm going to load in 0.1.0. So voxel demo 0.1.0 is contained within this bundle. If there were other things, like if I put jQuery into that bundle, I could also add it to this list. So as soon as there's a request to it, it'll go to the bundle. And with some luck, I think that should do it now. So if you look at the network tab, we load the initial page with our app build that we did just now. And when I click on the new functionality, it didn't work. So why didn't that work? I think it's 0.0.1. So you do have to get the exact name and exact version right. All right. So when I click the button, it just loads that single bundle, if you can see it in the network tab there. And it's then just like a Browserify bundle, loading the full CommonJS tree from within that. So yeah, that's it. That's pretty much what there is to it. It allows you to kind of package manage your existing modules today and bundle them up with these kind of workflows using an ES6 Module Loader. Right. And then there's one other thing I want to talk about, which is how we're looking at the future workflows of HTTP2. So I said at the beginning, bundling is actually an anti-pattern. It's something that we're going to be moving away from. How can this work when we're actually going to be looking beyond bundling? And one way we can do this is we basically take that JSPM packages folder, host it on your local assets server, and put that into production effectively. And because of the fact that the files are versioned, you get everything running through that. And there is actually a CDN set up as well, so you can actually run directly through that. And that core thing is that the config manages your full dependency tree and the exact resolutions. Right, so that's it. Some of the next things I want to work on include conditional loading. For example, in reality, I wouldn't just load a web component. I would want to do a conditional check on my environment to check that the environment supports web components. If it doesn't, load a polyfill, and have that conditional loading baked into the module system itself. And then to look at builds around it, and also thinking about internationalized builds and how you can do builds around different languages, and more build tooling for plugins as well. So those are the kind of things that I'd really like to work on next. Yeah, so that's it. I'm not telling you all to go off and start writing ES6 web components. What it's really about is focusing on an approach that can be based on the ideas of ES6, and you can use it for AMD, CommonJS, and existing workflows today. I mean, the real path to ES6 is much more nuanced than just using these kind of approaches. But by basing ourselves on these approaches, we can find a stable workflow that can make package management really easy, and that's the hope. So yeah, check out the projects. Let me know what you think. If you like it, if you hate it, it'll be great to hear it. So thanks so much for your time.